Okay.
It's not frosted. The glass is not frosted. So that if the glass is not frosted, the camera is not running. But now it's frosted.
Det var jag som tänkte på den.
Så ja, den.
Stream.
Green over there.
On. Mic is on.
Yeah.
Yeah. Now everything is working.
Yeah.
Almost. Yep.
Yeah, it should be okay.
I will fix that. Damn it.
konkurrerade en lastbil på natten, men sen hade det bara fått kylt det. Och så bara, men det var ingen fara på den. Så jag var där och
Okay, I think it's time to start today's lecture. And before starting today's lecture, if you have some questions from the previous, okay, then I suppose we can begin with. And today we will be learning mainly the two key concerns. The first one, we will start with the Java generics. So we will get a quick introduction what the Java generics are and why we need them, and how can we define generic types. And then a related concept will be Java collection framework. It's a set of APIs and classes that heavily depend on concept of generics, to deal with the set of data. So if you have a related kind of data of different types, so similar to the arrays. In the arrays we have like more than one data items that belongs to one data type. But in generics, it allows us to deal with the kind of multiple data items. But the problem with the Java array is like, I mean, if you don't use a generics kind of code, and if you have written one method or a class for one data type, for example, if you have written a method to add two integer values, and then if you want to do the same functionality for another data type, like let's say a double or float, then you have to define a new method or you have to write a new code to deal with another data type. But the Java generics enables you to write a code once, and then you can use that code for different data types. So you can choose, you can give a data type as a parameter at the runtime when you run the code. We will see how does it works. So yeah, so that's the first slide is just agenda, and I have already talked about what we are going to do in today's lecture. So as I said that Java generics enables the Java developers to write a code that can work with a number of different data types. And this feature was introduced, I think, in Java 5, GenericType 5, and there are two important things to get this kind of feature. The first thing is that you can have a generic types, and by types mean like classes. You can define a generic class, or maybe if you don't need to have the whole class as a generic, maybe you just need one method in a class, like in a simple class that you was writing before generics. So if you need only few operations that should work with different data types, then you can also have the opportunity to use generic methods. So instead of making the whole class or whole type as a generic, you can just make one method or maybe more than one method as generic. So basically, I mean, before learning the Java generics, there might be questions that why we need generics, and the reason I told you before that the first main reason is that if you have written a code for one data type and you want to use it for another data type, if you don't use the Java generics, then you have to rewrite the code for that kind of, or you have to re-implement that algorithm for that type, which is not kind of a nice thing. If you have done one thing, why? I mean, you have to do it again. And also, before the concept of generics, there were already concept of collection in the form of arrays and object class, because we learned that the object is the super type of all the types in Java. And what does it mean? That if you have an object of type object, then it can point to any data type. So you can use the object class to deal with the different types. But the use of the object class requires the explicit typecasting. You know that if you want to convert from one data type to another data type, you have to tell the compiler that I have this data type, I have integer data, but I want to convert it to something like a double or float or compatible data types. So, and there is another reason that often if you don't use generic features, so you might have incompatible data types in your code, but your compiler does not complain. So for example, it's easy to see an example. So let's see, I already have a code here. And in this code, I have used some library classes from the Java collection framework, ArrayList. And it's like the ArrayList is one of the most widely used Java collection classes. So it's so you can use ArrayList wherever you are creating the arrays. And the advantage of using ArrayList is like, I mean, in the arrays you have to specify the size. And if your array has become full and you have more data items, then you have to recreate an array. But ArrayList gives you advantage that it can dynamically grow and shrink in size. So depending on how much values you have in your ArrayList. And it also provides you with the useful API methods like search, sort, things like that. So if you look at this over here, so I have created an ArrayList, and basically the list is a super type. And it's an interface. We will see when we talk about more about the Java collection framework, because both list and the ArrayList, they are part of the Java collection framework, which we will be covering today. And here we have not specified what kind of data that list is going to have. It can have any kind of data. It can have a numeric, alphabetics, and character type of values. And I am adding different values. Like this one is like just a pure numeric integer without decimal points, and then there is a value with the decimal points, and then there is also a string, just for example. So I'm adding heterogeneous data that belongs to different data types. And then I have on this list I call the iterator method. So the iterator method basically returns an object of type iterator. An iterator in Java is an interface. It's a API interface, and all the classes that belong to the Java collection framework, they provide you with this functionality with the iterator method. And this iterator method, it returns you the object of type iterator, and you can use that object to traverse whole collection. So for example, if you have 10 values in your collection, you can use the iterator object to visit. For example, in the array, we use the array index. Like if you have an integer array with the name of student, string array with the name student, and then if you have different values, then you can use the index value 0, 1, 2 to access different values. But with the collection classes, you have this iterator object, and you can call iterator.next. So when you call the next method for the first time, it will return the first object in that collection. And if the collection is empty, of course, it will give you no such element exception or something like that. So right now, if you see here, I have added 3 values into that array list, and then I have received the iterator object, iterator, with the name of itr. And here, if you look at this code, no. When I call iterator.next, I have to explicitly specify that what kind of element I am going to get. If I don't specify the type of the element over here, so for example, if you skip this part, you get a compile time error, okay, type mismatch, cannot convert from object to int. So by default, because you know the object is the super type, so the return type of this next method is object. But what kind of object? We need to specifically tell the compiler that we are getting integer object. And why we are getting the integer object? Because we know that the next method returns the first element in our collection. And the first element that we added into the list was a 0, which is like an integer value. So I have to tell that I am getting an integer value over here. Okay. So that's why we specify that we get an object, but since that object is of type integer, we typecast into the integer. And then on the next line, iterator.next, it's the second object is of type float or double. It has a decimal points. But for example, as a programmer, if you have like hundreds of different values, it means then I have to remember the order, which could be like wrong. You could be wrong. At time you can make a mistake. You forget about what was the type of the second or 10th element in your collection or 20th element in your collection. You don't need to really remember that thing. Even if you say that I have a value of type decimal points, but I am forcing it to be of string, but there is no compiler warning, no compiler error. And the same going on here. Here I create another list, subjects. I added only one element of type string forced, but I am trying to convert this into the integer, and there is no compiler warning. However, when you try to run, if you try to run this code, at runtime there will be a problem, because at runtime string and integers are not compatible. If you are trying to force, there will be an exception. There will be a runtime error. So I just run this one, and you see that we get an exception, cross-cast exception, and double cannot be casted to something like a Java string object. Okay, so that's the problem. If you don't use the generics, our compiler will not tell us, will not provide us with the type safety. It will not validate the types at the runtime, at the compile time. But if we use the Java generics feature, we can explicitly specify what kind of list I am going to create, because now it's just a raw list. It can contain any object. For example, if we go here, if you see this code, list of subjects, and here I know that the subjects will only have a string type values, so I can specify the type here, string. And then you see that after specifying that type, immediately the compiler starts complaining that this subjects, you declared that this subject's type variable, the type of this subject type variable is a list of strings. It means that it contains string type values. And in this line of code, you are getting a string type value from a variable of type string, but you are trying to typecast into integer, which is not going to work. You got it? So this is the one reason why we need generics in our code. So it provides us with the type safety, and type safety is that a program is type safe if it compiles without errors and warnings and does not raise any exceptions at runtime. Otherwise, your program is not type safe. Okay, and then another reason is that before using this generics, the code we were using the object class. Of course, you can write a code with the object class that can work with the number of different data types, but then you have to explicitly yourself typecast every time that if you have used a value of type integer, then you have to typecast explicitly of using the same type as we have in the code that you see that here. So here we use the value of integers and then decimal. So I have to remember, I have to explicitly tell that what kind of value is going to be returned or my program is going to use. Another example as we say that in Java we have an object class. So we want to create a class, a type that can, we call it like an object container that can contain or hold a value of any type, integer, numeric, float, character, boolean, whatever. Or even the user defined data types. If you define your own data type, if you have created a new type, which we call a reference type in Java, if you have written a class with the name car, student, teacher, and you want to hold the values of that type. So we can create a container type or container object that can contain values of different types. Okay. So I written a class with the name of object container, which has a one attribute or a reference field. And since I want this object to contain any type of value, so I have chosen the object. Its type is of object, because object is a super type, and a variable of a super type can point to any values of subtypes. And then it just have a two getter setter methods. Okay, I will use the set method to set the value and get method to get the values, and the return types are accordingly objects. Now I have a main method. I have a code in the main method. I can use this class to contain string type values and also maybe integer type values. But the problem with this is that if I want to use this container for a string type values, then I have to create, and then I want to use it for the integer type value, but then for the integer type values I have to create a new object. Okay, so I have created a string container and I am putting a string type value, that's fine. And then I have created an integer container and I can use it for the integer. But why not we create one instead of creating a separate variables? Why not we write a code and then specify the type when we create the object of that class? So how we can do that? Here is how we can write a similar code to that example. Instead of using the object class, we can use the Java generics features. And how do we create a generic type? When you define your generic class, because this part is the same as you have in your normal class definition. We have an access modifier, class keyword, and then name of the class. And the name of the class can be any name, any identifier. But here, after the name of the class, if you want to create your class to be a generic class or generic type, you have to use this type parameter. This is like this is Java syntax. Within the angular brackets, you have to specify the type parameter. Okay, and this type parameter T is just an identifier. You can use any identifier. You can use any name over here. But by default, as a standard convention, we use the uppercase letter T for the type, and then there are some other convention that we will see later on. And now, instead of saying the object, we say that this T, you can see this T as a parameter that we use in a method declaration. So when we want to define how many variables, how many values, input parameters. So you can see this like an input parameter. And then at the runtime, we can choose the type of this. And then we have a T, okay, get object and set object. Now how we can use this generic container? When we are declaring, if we want to use it for the string data type, when we create an object of this generic container, here we specify the type, string. And this string, the value that you specify over here, the type that you specify over here, at runtime, it will replace this T over here. And similarly, in all the instances where you have used this type parameter. So this T, for this line of code, T will get replaced by a string. So for string container, so the object that you defined with the string container, with the name of string container, with the type parameter string, the type of this object will become string. The return type of this get object will become string, and it will return an object of string type. And for this set object, the type of the input parameter will become string. So this one we call as a type parameter, and the value that we provide for this type parameter, we call it a type argument. Same like method parameters and method arguments. And then if you need to define another one for the integers, so you can use it the same way. So for example, if I show you the code now here, we have an object container, and we have already seen the code for the object container. It's the same. We have an object of type object, and then set get methods. And then we have this object container main. For a while, I just comment this code, and now I'm only using this object container class, and I am creating an object and setting up. First, I am creating an object for string type values with the name of string containers, and then I am creating another object for the integer type values with the name of integer container. And then I also have a generic container here with the code that we have already seen over here. And now we have this main class, and in the main class I specify the type, and this type will replace the type parameter. You understand how does it works? That was like kind of a simple example to understand the concept. Now imagine that you have a task to implement a stack, and the stack is a commonly used data structure in computer science, and it works like with the last in first out. Okay, so if you have you can insert values into a stack, and then you can get the value, return the value. So if the function call, the method calls that the different programming languages implement, they work in a stack manner. So the methods, if you have called one method from another method, so once that method has finished, it will return back to its caller method. So if somebody asks you to write a stack, to implement a stack that can handle values of different data types, you can pass the values of integer type, you can pass the values of float, double, long, short, byte, and maybe even the user defined data types. So if you don't use the Java generics, then you have to write a separate stack for every data type. But if you use the Java generics feature, you can use the type parameter, and at runtime you can pass the argument value to that type parameter. Okay, and the syntax is again the same. For example, before looking this example, so if you have to define integer stack, maybe, so let me see if we have an integer stack over here. Yeah, something like a number stack, no? Yeah. Now, I mean, if you have to write the integer stack, then you have to develop an array list that can hold only an integer stack. But now you can use it even for the integer, even for the long and the other data types. What do we have in this class? Of course, we need some collection type class that can hold the stack values, like we were using previously. We were using arrays, but now we are using the array list. And then you have a constructor just for the size, and then we have the push and pop methods. The push method is normally used in a stack if you want to get, the push is for inserting, and the pop is to access or get something from the stack. Okay. We have seen how can we define a generic stack, and here we will see how we can use a generic type stack to deal with values of different data types. Okay, we have a stack of size 5, and then here, if you want that stack class that you have defined to hold integer type values, then when you are instantiating an object of that stack, you can pass integer as a value, as a type argument. If you want it to have the values of type double, you pass that as an argument here. If you want to use it as a value of type string, you specify the value as a string over here. And then it means that when you have used for this object the type parameter t in your generic stack definition, the t will get replaced with this data type integer. And for a string type, for this string stack, that type parameter t will get replaced by this data type value. Just a minute. So now I have created an integer stack with the size 5, and I'm passing some values in stack push 1, 2, and then I can just call some methods pop to return the values. And here I am passing some decimal point values, and here I am just passing values of type string. And it can, I mean, if you try to pass some other value over here, there is no problem now. But if, let's say, this is like double stack, and now I try to, it will automatically already give you the method push double. However, if you go into the implementation, we have not specified any type. We have instead used only the type parameter t. Okay. In this class stack main, the object we are constructing is of type stack. And if you go into the stack, into the code of this class, you see that we have not specified any specific type for its methods push, pop. Instead, we have used generic type parameter t. And this generic type parameter we need to specify, because we have not, Java is a strongly typed language. We must need to, whenever you are creating some variable or object or a reference type variable, you need to specify the type. But in the Java generics definition, we use this type parameter features to defer to delay this type specification until we create an object. So instead of specifying the type here directly in the code, we delay that step and we specify the type when we use it. If we have a different customers, some customer maybe wants to use that object for integer type values, another customer wants it to use for another type values. So we can customize it using this generic features at runtime. And how can we do that? We do it when we create an object of that type and pass the value within the Angular brackets as an type arguments. And if you try to if you have created if you have passed a wrong type value, before we saw that in the first example, when we were returning a string value, we were getting a string value and we were passing it to integer value, there was no problem from the compiler, there was no warning. But if you use Java generics and if there are some type incompatibilities, if the two types are not compatible with each other, then there will be some errors thrown by the compiler or the warnings. Yes, now your question, yeah.
I was just wondering, because you had, when you defined a stack
Yeah.
with integers, you wrote new stack and then you wrote in integers, but not for double and string.
Uh,
So I was just wondering if there's a...
what do you mean? I don't know.
When you define the stacks.
Okay, here.
You have integers, new stack.
Here, yeah, here you mean, yeah.
Exactly.
Yes.
But not for
This I just want to show you. I mean, if you don't specify the type over here, the Java compiler has a type inference feature. It will infer the type based on what you have specified over here. So if you have specified the double, it will automatically set the double type over here. So you can, I mean, it's just a time-saving tip. So it's I just want to show you a different way of writing the same thing. Yeah.
Does it work the other way around? So if
No, I don't think so. I don't think so. We can test it over here. No. It's fine. There is no big difference. So it's a type inference, and even if you don't write it over here, so there will be no problem. But you cannot leave it here. Yeah, you have to specify it there. Okay. So generic type is a generic class, or it could be an interface as well. Not only a class, you can also define a generic interface using the same syntax. That you put some access modifier, class name, class keyword, class name, and you can also have more than one type parameters. It's not necessary that if your class is dealing with more than one data types, so you can have as many as type parameters here, separated by a comma. Okay, and then you put your code and replace, use the t values as we have shown in the example. So you already have seen this example that how you can use the type parameters. Yeah.
You had T1, T2.
Yes.
I mean, do you have to specify T1, T2? Is it?
You can use any identifier.
So can I have the same name, T and T?
No, not same. Because then it will be. It's like you cannot have a variable with the same name.
Okay.
It should be, unique in that context. Okay, so here we already have. I think we already have saw this code. So I will just skip through this, and then type parameter and type arguments. And the difference between the two is like type parameter is the one that you specify when you define a class, and argument is that one that you specify when you are creating an object. Okay, so for example, and then here, I mean, it's not like you can use small letter as well, but it's not a recommended approach. The recommended approach is that you use capital letters. And if this parameter is representing a type like integer, float, long, double, then you should use T for type. And sometimes we also use generics for values that are key value pairs. So for example, in a hash table, so where you have a hash key and then a value associated with the hash key. So if you are using the type parameters for values of key value pair, then standard convention is to use the letters K and V. And if it's like the elements, for example, elements in an array, then we use the E as a convention. The next thing we have already seen the generic class and generic type, and the next is the generic method. So instead of defining the whole class, making the whole type as a generic, you can have like a simple class, and then in the simple class you can just define one method as a generic method. And the syntax for this is, the first part is same. You can have access modifiers like public, private, protected, then static keywords if you want to have your method to be a static method. But then before the return type, you need to specify the type parameter. This is the difference between, this is the only difference between generic and non-generic methods. If you have, before the return type, if you specified a type parameter, then that method will become a generic method. But of course, you have to define it in a both syntax-wise and semantically in a right way. And then you have a method name and parameter list, and then of course the body of the method and where you use it. So this is general syntax, but now we look at some example. So on the right side, we have a non-generic method, and on the equivalent side, we have left side, we have equivalent to that a generic method. Okay, so this method, the functionality of this method is that we passes a string and an array of strings, and it counts how many instances of specific strings in that array of strings are. So it's like a counter method. Okay, so for example, if we pass this string, which is containing HELLO, hello, okay, an array of strings, and we want to count how many letters L are there. Okay, so this function is basically taking an array of strings and counting a specific number of strings in that array of strings. But now this method, since we have defined it only for one type, we have defined it only for this type string, we can use it only for the array of strings. We cannot use it for array of integers. We cannot use it for array of characters or other data types. If we want to have the same feature, same function for the array of integers, then we have to write a new method. You already know method overloading, where you have a same method with the same name but maybe different parameters. But generics helps us. And how can we create a generic method that can take an array of any type and can perform the similar functionality? The way is over here. The first part is same, public, static, and then we use the type parameter because we want this method to work with any type. So we say that okay, T, and when we write this, compiler will immediately know that you are going to implement a generic method. And then int count, and here we use the same type parameter T because we want this method to work with an array of any type and count the values of any type T. And if you look at the other code, instead of wherever we are using string, like here string, we have replaced it with the value of T because we don't want that code to be specifically for a string type, but we want it for any type. Okay, so it means that now we can use this code to work with any kind of array of any type. So we already have a code for that, and generic method. Okay, here we have a non-generic one, and then at the bottom we have a generic method, and here we have a main method. And first we created an array of strings with the name of hello world, and then we are counting both these two have the same name. Okay, we know that in Java we can have two methods with the same name but not with the same signatures. So the parameters of the two are different. The one is with the string and the other one is with the generic type. So for example, now if for a while I comment my generic one over here, so the generic method is no more the part of this code, and I have two types of arrays over here. The first type is of string and the second type is of integer. There is no problem when I call this code count method, because I have defined my count method to work with the array of strings. But when I call it with the array of integers, there is a problem over here, because I have not defined a method that can take an array of integers and perform the functionality. On the other hand, if I remove this one, of course, now there is no count method. So now even if you remove this method from here and you just have only this method, it will work for both array of strings and array of integers, and if you have an array of any other data type. So let's see if we run it. Okay. In the hello world, we are finding the letter L, counting the letter L, and there are only like 2 occurrences of. And in the other, we are counting zeros, and there are 3 zeros. You understand how this generic code works, and how you can use it for generic any kind of data. Yes.
I can pass as many arrays as I want.
Yes.
I just write exactly the T.
You mean you cannot pass as many arrays? you can pass arrays according to the
Yeah, if I want another array in the method.
another type. Yes. Yes.
I can just use the same T.
Yeah.
I don't have to
Yes.
write T1 or T2.
No, you don't need to write T. If you want, something, some other functionality for another data type, then you need another parameter. If you need a same functionality for same type, then you don't need. If you have a different operation for another type, for example, key and values, okay, you want to treat the keys in a different way and the values in a different way. For example, in the hash map, we say that you cannot have duplicate keys, but you can have duplicate values. Okay, so in that case, we cannot use a single parameter. That's why we need K and V, 2 parameters. You understand? If you want to have same operations on your data items, or if you have a data items that are of the same type and will have same kind of operations, then you don't need another parameter. You can use only one type parameter and work with that. But if your functionality require that you have values either of different types or of different with different operations, then you need more than one parameters. Understand? Read about it and maybe play more. And if you still have a question, we can talk about maybe on the forum or during the practical lab sessions. Or so coming back to the lecture slides. So here is this is the same example, and you will get the example code with the lecture slides, so you can play with that as well. sometimes you might have because when you say that when you specify this type parameter can be replaced by any type. But at times you want to put restrictions. Okay, you want that your generic code can be used with specific types. It can only be used with maybe integer values or maybe string values or some specific type, not with any type. Then you can bound it. You can put limitations. You can restrict that your generic code should work with only this set of values. It should work only with this class or its subtypes, not with the other class. It should work with the class A, but with not class B. How can you do that? You can do it by specifying, by bounding it. So when you specify the type parameter, you can specify the super type. Okay, so if you want, otherwise it will work with any type. So for example, if we want to have a code that should work with the numeric values but not with the string values, we can extend this T with the type number. Now when we have a ArrayList, the same class stack, but we want it only for the integer values. So we extend it with the number. Now you can use this number stack. You can push number type values, will be fine. But if you try to push a string value, if you want to try this with the string value, but you will not be able to do that. You will get some compiler error. So for example, if we go here, like here we have defined this number stack and then number stack man, and here you are passing integer, fine, double, fine. But if you instead of number you say string, you immediately get a problem because you have bounded the number stack class. The type parameter must be of either a type number or subclass of it, where the string is not a subtype of number. Okay, you got it? So you can restrict what can be instantiated, what types can be used with the generic types. And also important feature is we learned in the previous lecture, we learned the concept of inheritance, subclasses and superclasses. So if you have, we know that the advantage of inheritance is that if you have written a code and then you can reuse it, you can inherit properties and you can add and customize things into the subtypes. And inheritance allows us that you can use the super type reference to point to the objects of any of its subtype. Okay, if you have a class A and you have a class B and C, which are the subtypes of class A, you can use the reference variable of type A to point to the reference variables of type B and C both. Okay, so now, but this substitution principle does not work with the generics. For example, we know that integer and double are subtypes of number. List of integers and list of double are these two classes or the objects of these two types. Can we point them by using an object of list of numbers? In the first, when we look at it at the first time, we see that okay, yeah, this is list is the same, list, and the number. And then we have integers and doubles, which are the subtypes of the number. So maybe the same principle can apply, but no. And why? Because integer and double, they are subtypes of number. However, a list of integer and list of double still remains the list. They don't become the subtypes of. You understand? This is a common, I mean, it's just a rule of thumb that often when you are writing a code, it becomes an easy thing to forget. So if you if you have a generic type, and then you have created a collection like a list on its subtypes, you cannot point it using the parent type. This is just an example where it's showing you that how, for example, if you have a list of integers, and then if you try to pass the reference to this into the list of numbers, you will get a compile time error, because a list of integer is not a subtype of list of numbers. And then we have another important concept related to the Java generics with the name of wildcards, the question mark. And you can use it as a type in a situation when you don't know what kind of data you are going to have, what type of the data will be. In that situations, instead of specifying, like if you don't know whether it will be a type or whether it will be something else, you can just put the question mark. And this, we can use the wildcard as a type parameter as a field, like like when you have a stack, a generic stack, where we have a t, and then we use the t to define the fields, local variable within the methods, and the return type. Although sometimes there is it's a philosophical debate about return type, that you should not use this wildcard question mark as a return type. It's not a problem with the Java. It's like something like a logical error that people say that you must always know what kind of data your method is returning. If you don't know, it could lead to problems in your code. And we have like 3 different types of wildcards. I mean, it's the 3 different ways that you can use the wildcards. We have the bounded. The 2 of them are like bounded, upper bound and lower bounds. And the one without bound is like if you don't specify any restrictions. So it's like putting some super and subtypes with the wildcards. What is unbounded and what is upper bounded is the same, like we already see that if you want to, you can use t extends some special class. You can bound the type parameters. The same way we can also bound our question mark. Okay. In this case, when we use the extend type, it means that the type that you can use should be either of the type that you specify over here or its subtype. Let's see, we have a code over here. We have a method, generic method, sum, and we are passing it list, and the first parameter to this is question mark wildcard extends number. It means that the values that we can pass over here, they are either of type number or its subtypes, integer and maybe double. So, and here you have an example. We have a list of integer, int list, and then we create a integer list and just print it. Yeah, and then we just have another list double and we use it. Then we have a similar code, print data list, and we have not specified any restriction. So it means it can be used with any type, integer, float, double, long, whatever. And then we have a third type, lower bounded. We have an upper bound, where we specify that the parameter, the argument for the parameter could be either a type or its subtypes. But if you want the other way around, then you can use the lower bounded with the keyword super. It says that the type parameter could be of the type or its supertypes, okay, but not the subtypes. So for example, if you say that, if you want that the parameters can be of type integer or the subtype of the integer, which is a number, but not any of the subtypes or of any other types, like double. Double is not a supertype of integer. So you can use this method for the values of type integer and number, but not with the values of type double, because double is not a supertype of integer. You understand the difference between upper bound and upper bound? You use it if you want to use for the type and its subtypes. Lower bound, when you use it for the type or its supertypes. And we have just an example wildcard demo over here. If you see that we have three methods in here. The first one is like unbounded, and it is just printing a data, and that data can be integer, numeric, and string type, any type. So we are using it here, print data, and I am printing it for the integer list, list of type number, and list of type double and string. So no problem, because there is no restrictions. And then we have an upper bounded method that's demonstrate an upper bound, and it's sum method. So and here we have a list. It gets a list and give us the sum of the elements in that list. But since we have specified an upper bound with the type number, so it can work with the number class and its subtypes, integer, double. But then we have a lower bounded wildcard, and in the lower bounded wildcard, we say that it should work only with the integer type or its supertype. So, and the name of this method is intsum. And here we have the different array list of different type, integer, double, and number. Now, if you see that I am calling this intsum method on the list of type int, it's fine. But if I call on the list of type double, it gives us a problem. Why? Because in this intsum method defined over here, we have a lower bound, and this lower bound specifies that it should use with the type that you selected or its supertypes, but not other types below or on the same level. Okay. So with this, we come to an end to the part that deals with the generics, and we will have like something like 10 minutes break, and after that we will continue with the collection framework. And before that, if you have questions, we can take now or during the break. Okay, so 10 minutes break. What? Unlock it again. Okay, sorry to interrupt you. It's time to go live again. So the next part in today's lecture is Java collection framework, and as I told you in the beginnings, basically collection framework is a set of classes and interfaces that we use to deal with the set of data, the elements, more than one data items, to store, retrieve, and maybe process if you have data items of a type, or maybe of different types, and then you need to process them. Then you maybe need these collection classes, so something like arrays. So and the Java provides you with its own API classes that you can use to handle collection of data. So here is some of the key interfaces and classes in the Java collection framework API. And if you see in the hierarchy, at the top we have a collection and the iterable interface. So that shows that these are the like root interfaces in the Java collection framework. And these two iterable, basically it provides you the functionality that if a class is implementing this interface, then you can traverse or iterate its elements using the iterator object or the for each loop in the Java. And then the collection interface, it defines the basic operations for a collection like add, remove, find, contain, size. We will see what kind of different methods are there. And on the second level, you see there are three major interfaces: the list and set, and the third one is the queue. And then there are like different implementations. The elements on the top or maybe on the middle, they are more like interfaces and the abstract classes. So they are not like concrete classes that you can use. They instead define maybe the interface, the methods for that API, and some abstract functionality which you can extend and implement depending on your own needs. However, it also provides you with some default concrete implementations like ArrayList and linked hash set, hash table, and things like that. So there is some fundamental things about the framework. So you can find all these classes and interfaces in the util package. And yeah, all the classes in this framework, they're implementing the iterable interface, which means that you can use the objects of that and iterate them either through the for each loop or through the iterator object. And here are some of the key interfaces, and I already, we get a picture over there. And instead of discussing them over here, we will see all of them one by one. So beginning with the collection, which is the root interface, and this UML picture gives you an idea of what kind of methods you have over there. And we can group these methods into four major groups. So the add elements, remove, and something to probe like query, if you want to see whether that collection contains a particular element or not, and maybe the size, and if it's an empty or not. So these kind of things. For the add, we have like two different methods: the add and add all. So if you want to add just one element, you can simply use the add method. And if you want to add more than one element as a collection, so then you can use add all. So these methods are kind of self-descriptory. So you can just use the API documentation and read about them. And we also have this iterator methods that you can use to traverse So we have an example over here. So it's a rather trivial example that how can you use, and I think we have already seen the examples of using the ArrayList class when we were learning about Java generics in today's lecture. So this example program just demonstrates that how can you use the different methods like add, and how can you use iterator to traverse, remove, and also yeah, the different other methods. And the next we have this list interface. The difference when we saw the picture, the bigger picture where we have this hierarchy of different classes and interfaces. So we can do more or less the same things using any of the different classes like list or set, but there are some fundamental differences. For example, in the list, if you can have a duplicate values, but in the set, it's like similar to the concept from the mathematics. We cannot have a duplicate values at the elements in a set. So if you want to have your collection to contain only the unique values and no repetition, so then maybe you can use set interface or a class that implements the set interface. But on the other hand, sometimes you might have a collection of data that contains duplicates that allows to have duplicate values. For example, if you want to have a list of students in a class, so students in a class can have same names. So in that case, maybe you don't need to use the set. If you use a set, it will not allow you to have duplicate elements. And other than that, it's also like the list is called as an ordered collection. And what does it mean by ordered collection is like we use an index. Every element that you insert in a list will get some index value. Like we start the list from 1, 2, 3. But in computer science, we know that the index starts from the 0. So, and we can use the index both to add and also to find and remove the values. But in the set, there is no order. You cannot use. We don't know. We only know that whether a set contains these values or not. So you can do that operation, but you cannot say like, okay, I want to get the element at this position. No, that's not something that the set supports. And the same is like with the queue. The queue also allows to have duplicate values, but the difference between the list and the queue is that in the list you can access the element from any location, from any index, but the queue it provides you access at the ends. Either you can see it from the front or from the bottom, not maybe in the middle. You have to go through traverse one by one. And the list it's a subtype of collection, because the collection we saw that it's a supertype. So it means that all the methods that we have seen in the collection interface, they are also part of the list and the other subtypes of the collection. But in addition to that, it also provides you some other methods. Okay. So some of the additional methods you can use, for example, over here that you can, of course, when you add the element, it adds the element at the end of the list. Okay, but sometimes you don't want your element to be at the end. You want maybe at some specific position. So then you can use the other variant of add, and then you can specify the index position. So if you want to add the element at position 5, 10, whatever, and then you can also get and remove, yeah, and the set, yeah. The difference between the add and set is like if you use instead of add, you use the set, it will replace the old value with the current value. And then you can also use the index and the last index. The difference between the index of and the last index is because in the list we know that list can contain a duplicate values. Okay, so if you use the index of object, it will return the index of the first value. But if you want to find the index of the last value, then you can use the last index. So these are just the API methods, and you can if you want to have some functionality, of your own, of course you can, because it's an interface, and we know that we can implement an interface and add our own method. So you can create a new class that implements this list interface, and then you can add more methods. Yeah, the sublist, yeah, if you want to get, I mean, if you have a list of 100 students and you want to get maybe first 10, last 10, so you can extract the elements, and then you have to specify from which position that you want to retrieve. So these are the different, I mean, so since we know that the collection framework we use to process collection, data as a collection, okay. And this is just an example. So again, yeah, you can see over here. So, and if you see over here, because we cannot, we know that the list is an interface, so we cannot create an object of type list. However, we can create, we can use this as a instance, as a reference variable, and create an object of a class that implement this interface. So in this case, we know that the ArrayList is actually implemented, is a subtype of the list. So we are using it, and then we are calling the various methods. So this example just shows you that how you can use the various methods from the list interface. And as we know that list is an interface, so we cannot create an object of that. But then the Java collection framework provides us with few of its implementation classes, like the concrete classes. And one of the most widely used is the ArrayList, as we already saw that. But then other than that, ArrayList, you can also use the linked list. Yeah. Okay, and the vector class. A vector is nowadays kind of an obsolete, so it's hardly used, but these two, they are still more in the use. The difference between ArrayList and linked list is ArrayList, it's actually on the back end of the ArrayList, it's array that the Java arrays are used to hold the values. But it allows, I mean, it gives you a freedom to not bother about the size of the array. So you can create an array list without specifying the size, unlike the arrays. And in the linked list, instead of arrays, we use the linked list data structure and the double linked list. We will learn about the linked list if you are not familiar with the linked list concept. So it's a data structure that connects the elements using some pointers. So we have if you have a first element and then you want to connect it, so you have a next pointer that is pointing to that element, and then if it's a double linked list, then it's also pointing to the link. It also maintains a pointer to the previous elements. So the pointers to the, it's like a chain. You have a data that is linked together in a chain, and each element points to the element to the next, and also to the back or the previous to it. And the difference, other than that, other than the implementation, these different classes also differ in the performance. So for example, the get operation is quite fast if you use the ArrayList. However, it's a bit slower if you use the delete operation. Why? Because in the you can get the element from any position from the ArrayList by passing the index value. But if you delete one element, then you have to shift all the elements, and then it means that you have to visit all the elements. Okay. So for example, if you have removed the last element, it means that you have to force and visit all the elements. But on the other hand, in the linked list, the remove is only from the one end or the other end, so it's a bit faster than ArrayList. And the vector is why sometimes we use vector, because it's synchronized. What does it mean by synchronized? That if you have multiple threads in your application, so it doesn't allow more than one thread to access the elements at the same time. And the advantage of that is, like, if you have not synchronized, either you have to make sure that by yourself that no more than one thread can access an element at the same time, because if they access at the same time, then one can manipulate the value and if the other is accessing that element at the same time, so he might get the old value instead of the updated values. So, and another difference is that ArrayList by default it grows by 50%. If you have initially, like in the array there were like 10 elements, and then if you added 11th element, so it will increase from 10 to 15. But on the other hand, the vector will grow from 100%, like 10 to 20. So these are like some tiny details about them. Then we have a set interface, and the major difference between the set and the list is that it allows duplicates, and it's also not ordered. There is no sequence of the elements. In the list, there is always a sequence. So every element that you add will get some index, will have some position. But in the set, we don't have any position for the elements. They are like, we even don't know. Okay, and but the advantage is that it allows you to have a unique values. So this is just an example, like it's a scenario that where you can use the set instead of list. And the simple example is that if you want to find the unique instances of something, then you can use a set. And similar to the list, set is also an interface. So it means that you cannot use or instantiate it directly. However, there are implementation classes from the collection framework. And the three of them, the most widely used, the hash set, linked hash set, and the tree set. And hash set, in the hash set we use a hash table based mechanism. And what is a hash table? It's like in the arrays, we use the index values like 0, 1, 2 to place and then to retrieve the elements in the array. But in the hash table, we have hash code. So whenever you have a value that you want to store in the hash table or in the hash set, you have to compute the hash code, which is like a kind of a unique code. And then you can use that hash code to find out the location or to point out the location. We will see with an example that how this hashing mechanism works. And the linked hash set is basically kind of a mix-up of both the hash table and the list. Okay, and it allows you to have a bit slower than the hash set operations, but still it's faster than. We will learn more about these when we, I think, after the next week, there will be more details about time complexity. We will learn how to estimate how much time the different data structures need to search and find and add and remove operations. So for now, I mean, you can just simply maybe not worry about these things, that how you find out this big O, what is the big O notation and what is the complexity. If you're not familiar with that, we will come to that to move with more details in the coming lectures. So this is how this hashing thing works. So for example, if you have like an array, if you have a place, if for example, if the chairs in this room, these are like buckets where you can put some values. And then if you know that you have like 64 chairs, so it means that your hash code should be between 0 to that limit, 63. Okay, so it means that you need to write some function. That function should map your data or your values to those buckets that you have. So you get an element, and then you compute or determine the hash value for that element. It means like you write a function, maybe the hash function, that returns you an integer value, and you use that integer value to find out the position for that element in your hash table. So for example, if we have the values of type string and we want those string values to place in our hash table, how can we do that? Any idea? I mean, there could be different approaches. You can come up with your own algorithms. But one common thing is like, okay, we know that every character in a string has some ASCII code. So we can compute the sum of the ASCII codes, or maybe some other operation that can map, that you can map to the your index position in your hash table. So for example, we have the string hello, and we compute its sum of all the ASCII codes for all the letters. So for example, we know that ASCII code for the capital H is 72, for the E is 11, and for double L 108 plus, and this is the value we get, 500. And then we know that the size of our hash table is 64. There are only 64 positions. So we can use the modulus operator, and we get to find out where we should fit this 52. Okay, because it will also, the modulus will also give you, when you with the values in the range from 0 until that less than that element with which you are dividing it. And the Java, I mean, the object class, which we know that it's a parent class for all the types, and it already prepares its objects for this hash code functionality. If you go into your object class, you will find this hash code function. It means that you can write, when you define a class, you can use this hash code function, and you can write a code to compute the hash code for that. And Java also uses this hash code to determine why the two objects are equal or not. Okay, and if the two objects are equal, then they should also have the same hash code. If you have a two, because if your hash code function, if you call the hash code function on, for example, we have this value. The property for the hash code function is, if you call the hash code function on a value, on a same value 100 times, it should give you the same value. It could not be like that, the first time you call it gives you a value of 52, the next time you call it gives you some other value. That's not a right function. It can also be possible that it is okay if your hash function gives a same hash code value for two different input values. That is fine. But if your hash code gives you a different value for a same input, then it's a problem. Okay, so it means that if two objects are equals, according to your semantics that you have written in the equals method, then the hash code for those two objects should be same. But on the other hand, if the two objects have the same hash code, it doesn't really necessarily mean that they are equal, because two different objects can have same hash code. And we use this hashing mechanism when we talk about the hash table, or we talk about the linked hash set, to determine the position for the elements that you are adding into that collection. The next thing we have is the queue interface. The queue, you can have duplicate values, but unlike list, there is no special index. And the queue, the general property for the queue is that opposite to the stack, where you have a last in first, in the queue you have a first in first. The idea of the queue is to implement something like a queue in a real life, where if you have for example, if you have a problem that wants to process the data or the applications. So for example, if you are writing a code to manage your resources like a CPU, and that handles, you are writing a code for the request manager. So the one application that sends the request at the first should get a request, should get the response at the first. So for this kind of scenarios, you use the queue or some of the subtypes of the queue. And the methods in this interface, they are normally grouped into two categories: throw exception and runtime. It's basically both give you the same kind of functionality, but in this group, if there is a problem, they will throw an exception that you can handle at runtime. On the other hand, the methods in the second group will, instead of throwing the exception, they will return. But I don't see any difference logically. They can be used in the same way. You can, I mean, if you get a special value and then based on checking out that value, you can throw the exception by yourself. And then we have a map. It's a slightly different than the other three types: set, queue, and list. Because in those types, we were talking about only single element or single value. However, sometimes we have values which are like a pairs that have some connections between each other. So, and we call them like key value pairs. So, for example, books in a library, they have like some identifier like book ID, student ID. And in that case, even the person, every person has a unique personal, depending on his country, maybe have a unique identifier. So similarly, in our the data you are handling or processing could have some key values, and you want to process that data in association with their key values. So for that kind of situations, we use the map interface. And some of the basic concepts about the map is like in a map collection, you can have values with the duplicate values, but the keys will always be unique. You cannot have same key in a one map collection. And then we have some methods similar to the one we have seen. Add associations, like if you want to add the put, and then we have a put all. So the difference between the put and put all is like if you want to add one pair, then you use a put. If you want to add more than one pairs, then you can use put all. And the same is remove associations. If you want to remove all, you can use clear. And if you want to remove only one pair, then you can use call this remove value with the key value, and it will remove that value. And then we also have query methods if you want to find if that map contains special value or not. And then also another important difference between map and the other interfaces that we see is that the map is not a subtype of collection, which means that it doesn't implement the iterable interface. However, it provides you with the methods, and that methods returns you with the values of the set type, because internally the map treats the key value pair as a set. So, and then you can, once you have retrieved those as a set, you can use those set type objects to traverse, to visit them. So, for example, key set and values. The key set, it will only give you a set of keys, not the values. But if you want to get the values, then you can call the values method. And if you want to get the whole, both keys and the values, then you call the entry set method, which will return you both the whole map as a set. And then we have some implementation for the map. So similar to we have for the list, we have a linked list, we have a array list, and we have also the vector. For the set, we have different implementation. Okay, and the same is for the map. We have a different implementation. So the first one is the hash map, and it again uses a hash table to map the values. And then there are some other properties. So it permits, we know that in the hash table, we have a hash table as well, but in the hash table, you cannot enter the null values. However, in the hash map, it allows you to enter. These are just the different, characteristics of these. Maybe you don't need them. It depends that what kind of application that you are developing. For some applications, maybe you can write that implementation using a simple array list. But maybe for some other, you need a hash set, or maybe you need a hash map. So, and you can determine and you can choose them only when you know their properties. What are the characteristics of these different variables? And then we also have the linked hash map, which is a combination of internally it uses both the hash table and also the linked list. And then it differs from the hash map in the iteration order, because the iteration order is predictable, normally in the order in which the keys are inserted. On the other hand, in the hash map, there is no order. You can get values in any order. There is no order maintained. However, if you want to have the order, then maybe you need to use a linked hash set. And then we also have a tree map, okay, that uses a red-black tree based map implementation. Okay, it's a data structure that we will learn more when we go to the tree data structures and the graphs in the coming lectures. And it uses comparator interface. So the comparator is an interface in the Java API that you can use to compare your objects and find whether the two objects are equal or not. It has a compare to method, and that compare to method returns integer value. 3 integer values are often used. 0, if it returns 0, it means like the two objects are equal. If it's return 1, then it means that the object that you are comparing is either greater, or if it's the less, then maybe the -1. So you can just check. I'm not really sure which one is for the less than or greater than. It is either a 1 or, but it's something that you can find in the API. Okay, this brings us to the end of today's lecture, and as usual, I have suggested some chapters and the tutorials. So if you like to read out more about the concept that we covered, and of course Sherlos will be here for another an hour and more, and you can also post the question on the Moodle. Okay, thank you for today, and see you in the next week.